Hello everyone, welcome back to DSA plus AI agent series. In this video, we are going to solve Leetcode problem number 525, contiguous array. This is a very important problem because it teaches us how prefix sum and hash maps can be combined to find the longest subarray satisfying a particular condition. Let's first understand the problem. We are given a binary array called nums. A binary array contains only zeros and ones. We need to return the maximum length of a contiguous subarray that contains an equal number of zeros and ones. The word contiguous is important here. It means that all the elements of the subarray must be next to each other in the original array. For example, suppose the input is 0, 1. This entire array contains 1, 0 and 1, 1. Therefore, the answer is 2. Now consider 0, 1, 0. This entire array contains two zeros and one 1. So the complete array is not balanced. However, the subarray 0, 1 and the subarray 1, 0 contains 1, 0 and 1 1. Both the two arrays contains 1, 0 and 1 1. Therefore, the maximum possible length is 2. Let's now understand how to solve this problem. The most straightforward approach would be to generate every possible subarray. For every starting index, we can move towards the right and count how many zeros and ones are present. Whenever the count of zeros becomes equal to the count of ones, we update the maximum length. The code for this approach would be two nested loops. The outer loop would select the starting index and the inner loop would select the ending index. This approach would take approximately n square time. Since the array can contain up to 1 lakh elements, an n square solution would be too slow. Therefore, we need a more efficient approach. Let's think about what it means for a subarray to contain an equal number of zeros and ones. Suppose a subarray contains 3 zeros and 3 ones. The counts are equal. Now imagine that we replace every zero with a negative 1. We will treat 0 as minus 1 and 1 as plus 1. For a balanced array containing 3 zeros and 3 ones, the total sum will become minus 1 minus 1 minus 1 plus 1 plus 1 plus 1. The sum is equal to 0. Therefore, the original problem can be transformed into the following problem. Find the longest contiguous subarray whose transformed sum is 0. We do not actually need to modify the input array. We can simply maintain a variable called balance. Whenever we see a 0, we will decrease the balance by 1, and whenever we see a 1, we will increase the balance by 1. Now let's understand how the prefix balance helps us. Suppose the balance at index I is equal to some value. Later at index j, the value becomes equal to the same value again. This means that the elements between index I plus 1 and index j have made no net change to the balance. In other words, the total balance of that section is 0. A balance of 0 means that the section contains an equal number of zeros and ones. Let's let's take a simple example. We will treat 0 as minus 1 and we will treat 1 as plus 1. Okay. Now initially the balance is 0. At index 0 the value is 0, right? So we will treat 0 as negative 1, so the balance will be minus 1. At this index the balance will be minus 1, and the index 1 the value is 1, so we will add 1 because we will treating 1 as plus 1, so minus 1 plus 1 is 0, and these are our balance. The balance has returned to 0. This means that all the elements processed so far contain an equal number of zeros and ones. The subarray from index 0 to index 1 has length 2. Now let's understand it again with another example. Suppose initially the balance is 0. This is our array and these are the indices of this elements. Now at this index, at 0th index, the balance will be -1 because we are treating zeros as -1. So we will do a -1 in the balance, and coming to index 1, the value is 1, so we will add +1 to the balance. So -1 will become 0, right? Now at this point we can see that this the balance become 0 again. The initial value of the balance was 0 and again the balance is become 0. Now we will see that the length of the array from the initial is length 2. So this is the current sub array. So this is the current longest sub array that has equal number of zeros and ones. So we will update the value as 2, our answer. Now come at index 2. Now we will see that there is the value 1. So we will again add 1 because 0 plus 1 is 1. Now at an index 3 the value is 1. So we will add +1 to our balance. Now it is become 2. Now at index 4 the value is 1. So we will add +1 in the balance. Now index 5 the value is 1. So we will add +1 to our balance. Now at index 6 the value is 0, so we will -1 from balance. So 4 minus 1 is 3. Now we can see uh, the balance was 3 in this position and it has become again 3. Now uh, we will see that this subarray has length 2. So we have already um, the longest sub array that has equal number of zeros and ones was length 2. So we'll not update that because we have already length 2 array. Now we will go to the 7 index. The value is 0, so we will do a -1. Now the balance has become 2. Now we'll see that this balance is repeated again, right? Now we will see that this subarray has equal number of 1 and equal number of zeros, and the length of the subarray is 4. So we will update our answer. Now coming at index 8, we will see that the value is 0. So we will subtract 1 from balance. It will become 1. Now we will see that 1 is repeated again, right, in this. So we will see that this subarray has the same number of 1 and same number of zeros and the length is 6. We will update that. Now how we will know that this is the subarray? We will make a hash map or dictionary and put these as keys. Okay, and these and the values will be these indices. And what we will do, see that uh, at this position at seventh index we found that there is already we have already seen the balance 2 earlier at index 3, right? So we will do a minus operation from 7 minus 3, the indices values. 7 minus 3 is 4, so we updated 4. At index 8 we saw earlier balance at index 2, right? So 8 minus 2 is 6. So we will do like this. So why do we need a hash map? We need to remember the first index at which every balance was seen. For example, suppose balance 2 was first seen at index 3. Later balance 2 is seen again at index 9. The elements between index 4 and index 9 must have a total balance of 0. The length of this subarray is 9 minus 3 is equal to 3. No, sorry, 9 minus 3 is equal to 6. Therefore, we use a hash map called, we can call it anything like first seen. The key will be the balance and the value will be the earliest index at which that balance appeared. Now we have one important thing here. Let's see one example again. In this example, the first index is 0, the balance will become minus 1, and at index 1 the value is 1, so the balance will become 0. Now according to our algorithm, what we thought before, that we will do a minus operation, but in this in this thing we what we will minus, right? uh, we have seen that the length is 2 and these have 1 0 and 1 1, so this the answer should be 2, right? But uh, what will be the minus operation here? So think that if we put in the hash map beforehand, that at index minus 1 the balance will be 0, then this can be a reason, right? This is the this is one of the most important part of the solution. Before the array begins, our balance is 0, right? We represent this imaginary position using index negative 1. Suppose the balance becomes 0 at index 1. The length of the balance sub array starting from index 0 will be 2, right? So if we do minus operation, 1 minus negative 1, it will be 2. So this will be our logic. Without storing balance 0 at index negative 1, we would fail to correctly calculate balanced subarrays that start from index 0. So we will put one um, one key value pair at our dictionary, that is 0 comma minus 1. There is also one thing that we have to store only the first occurrence of the key value. Suppose balance 1 is first seen at index 2, then balance 1 appears again at index 5. It may appear once more at index 10. To obtain the longest subarray ending at index 10, we should use the earliest occurrence. Using index 2, the length is 10 minus 2 equal to 8. If we replace the stored index with 5, the length would become 10 minus 5 equal to 5. That would give us a shorter subarray, right? Therefore, whenever we see a balance for the first time, we store its index. Whenever the same balance appears again, we do not update the stored index. We only calculate the possible subarray length. Let's now discuss the algorithm once again. First, create a hash map and store balance 0 at index negative 1. Then initialize balance equal to 0, maximum length equal to 0. Now traverse the array for every element. If the element is 0, decrease the balance by 1, otherwise increase the balance by 1. After updating the balance, check whether this balance is already present in the hash map. If it is already present, calculate the current subarray length by subtracting the first stored index from the current index, then update the maximum length. If the balance is not already present, store the current index at its first occurrence. Finally, return the maximum length. Let's do the code. This is our hash map or dictionary. We have put our first key value pair, that is 0 and -1, that we discussed here. This means that balance 0 was present before the array started. Next, we will initialize our two variables, that is balance and maximum length. The balance variable keeps track of the difference between the number of ones and zeros. You can think of it as balance equal to number of ones minus number of zeros. Then we will iterate through the array using enumerate. Enumerate will give us both the index and the current number. If the number is 0, we will subtract 1 from the balance. If the number is 1, then we will add 1 to our balance. Now we will check that if the balance has appeared before, then the section between the earlier index and the current index contains an equal number of zeros and ones. Now we will calculate its length. Then we will update the maximum. If the balance has never appeared before, we will store its current index. Remember that we store only the first occurrence of a balance. Finally, we will return the maximum length. Let's do a dry run. Now this is our array and these are the indices. Now we have to put the first key value pair, that is 0 -1, 0 and -1. Now at index 0 the value is 0, so the balance will become -1. Now we have encountered the first balance that is unseen, that is -1. So we will add to the map -1 as the key, and the value will be our index, that is 0. Now at index 1 the value is 1, so the balance will be 0. -1 plus 1, that is 0. Now we have we will see that if map has already present a key, that is 0, so already present 0 for -1 index, so we will do a minus operation, that is 1 minus -1, so it will be 2. So our answer, that is the maximum length, will contain 0. Now at index 2 the value is 0, so the balance will be -1. Now we'll see that in the map The minus 1 is already present, so we will do a minus operation for index 2 minus 0, that is 2. So maximum length is 2. We will not update that, so we will return the maximum length. Let's do the dry run for a larger example. The example is this. Now we will first uh, insert our first key value pair, that is 0 and minus 1. Now the balance is 0 for indices minus 1. At index 0 the value is 0, so the balance will be minus 1. Now the balance minus 1 is new, so we will add to the map minus 1, and the index is 0. At index 1 the value is 1, so the balance will be 0. Now we'll see that this 0 is already present in the map. The value is minus 1, so we'll do a minus operation with the indices, that is 1 minus minus 1, that is 2. So max length will be 2. Now at index 2 the value is 1, so balance will be 1. This balance is new for us, so we will add to the map, and the value will be 2. Now at index 3 the balance will be 2. The balance is new for us, so we will add to the map, that is 2 comma 3. Now at index 4 the value is 1, so the balance will be 3. The balance is new for us, we will add to the map 3 comma 4. Now for index 5 the value is 1, so the balance will be 4. Again we will add it to the map 4 is to 4 comma 5. Now at index 6 the value is 0, the balance will become 3. We will see that 3 is already present in the map, and the value is 0, so sorry, the value is 4, so 6 minus 4 is 2, so the maximum length will be 2. Will not update that. At index 7 the value is 0, the balance will become 2. So we'll see that 2 is already present in the maps, and the value is 3. So 7 minus 3 is equal to 4. The maximum length will be updated, that is 4. At index 8 the value is 0, the balance will become 1. We'll see that map has already present one key with the value of 2, so 8 minus 2 will become 6. The max length will be 6. We will return 6. Let's run this code. Let's discuss the time and space complexity. We traverse the array only once, therefore the time complexity is big O of n. For every element, hash map lookup and insertion will take big O of one time on average. The hash map may store a different balance for multiple positions. In the worst case, it can store big O of n balances. Therefore, the space complexity will be big O of n. Let's discuss some common mistakes. The first mistake is forgetting to initialize the first key value pair, that is 0 comma minus 1. Without this initialization, balanced subarrays starting from index 0 will not be calculated correctly. The second mistake is updating the stored index every time a balance repeats. We must store only the earliest occurrence because the earliest index gives us the longest possible subarray. The third mistake is directly looking for a prefix balance of 0. A balanced subarray does not always start from index 0. Whenever the same balance appears twice, the section between those two positions is balanced. The fourth mistake is trying to use a normal sliding window approach. Sliding windows work well when increasing or decreasing the window changes the condition predictably. In this problem, the balance can increase or decrease depending on whether the next value is 0 or 1. Therefore, a standard sliding window approach does not work reliably. The fifth mistake is confusing a subarray with a subsequence. A subarray must contain consecutive elements. We are not allowed to skip elements. Now let's quickly recap the complete idea. We need the longest subarray with an equal number of zeros and ones. We treat 0 as negative 1 and 1 as positive 1. Now a subarray containing equal zeros and ones will have a total balance of 0. We calculate a running prefix balance whenever whenever the same balance appears at two different indices. The section between those indices has a total balance of 0. We store the first occurrence of each balance in a hash map. Using the earliest occurrence allows us to calculate the longest possible subarray. The final time complexity is big O of n, the space complexity is big O of n. That is the complete solution to Leetcode problem number 525, contiguous array. Thank you for watching. Try to write the solution once without looking at the code. That will help you properly understand the combination of prefix sum and hash maps. I will see you in the next problem of the DSA plus AI agent series. Thank you.